revision, okay? We're going to do these 3 problems in particular ways. And as I'm going through them, I'm just going to draw your attention to parts of the way we solve these questions. I'm not even going to finish them, actually, some of them. This one I'm not going to finish. I just want to show you how it's done. And I want you to think about what's the common thread that binds all of these questions and our approach to them. What's the common thread that draws them together? Okay. Now, let's have a look at the first one. X squared plus 2x minus 9. Yeah, definitely. It does not factorize nicely, so you have one of 2 choices of ways to solve it. What are the 2 choices? Number 1, quadratic formula. Number 2, completing the square. Okay. Now, even though you don't usually do it, I'm going to make it a completing the square question. Okay. How do we do it? Let's kick this 9 over the other side. And then here comes the completing the square bit, right? I have to add something to both sides. What do I add?
1.
In this case, I add 1. You look at this coefficient, you halve it, and then you square it. Halve it gives you 1, square it gives you 1. So x squared plus 2x plus 1 equals 10, added to both sides. The reason why we added 1 is because it makes the left-hand side a square. That's why it's called completing the square, right? Okay, so you factorize it, and then you take the square root of both sides. Don't forget that that means on the right-hand side you've got 2 solutions. Then just to finish it off, you toss that 1 over the other side. Great, okay? Same thing that you would have arrived at if you did the quadratic formula, because the quadratic formula is just that in formula form. Okay? All right, this question. Now, when you look at it, what kind of a question does it look like? Right, this is, well, this equation's not a quadratic, but we can twist and turn it to make it look like one, right? What would be a good substitution to introduce?
X2 to the power of x equals y.
Yeah, okay. We tend to, by convention, we tend to use u, usually because y is somewhere else in the equation, but it doesn't matter. Okay. If u is equal to 2 to the x, then u squared is 2 to the x all squared, right? But by your index laws, you remember that that 2 and that x, they're interchangeable, okay? So this is really 4 to the x, okay? Yeah? So this is u squared plus u minus 1 equals 0. And then you can deal with it however you like. You can do this, or you can do the formula. You get a solution at the end, but you understand how it works. Right, now, we've learnt just recently a new method for solving equations like this, okay? So let's use our t results. Let's, you've let t equal this, and you've recited what's sine, what's cosine. Your results should look like this. 2t plus 1 minus t squared. Okay, so you multiply through. Bring your 1 over, so these are going to disappear. Bring your t squared over, so you're going to get 2t minus 2t squared. Okay, you can divide through, and you can also factorize while you're at it. So you're going to get these 2 values, and of course that's tan of x on 2. And then you go ahead and you solve that. Okay, you get 3 solutions, mod 2 pi and pi on 2 from memory. Okay, but that's something you guys are in now. So, what's the common thread? 3 different, quite different kinds of questions. What binds them together? Apart from that they're quadratics, that's actually a coincidence.
Multiple solutions.
Okay, number 1. Yeah, there are multiple solutions to every different question.
Algebra.
There's algebra. Okay. Now, more than algebra, and this is actually sort of getting at what I want to draw your attention to. Each time we've kind of used an algebraic trick, right? We've done something like this rearranging, which very conveniently gives us a square, or here this substitution, right? Or bringing in this totally separate thing, right? Which allows us to rephrase the question. So here, this is not a perfect square, right? So you do what you need to make it a perfect square. And this is not a quadratic, but you do what you need to make it a quadratic, and then you know how to solve that. And this, well, it's not, they don't fit together nicely, so you do what you need to make them fit together nicely, then you solve it, okay? So when you first learned these 3 methods, right, the whole idea is we're trying to rephrase a question in terms you already know how to solve. Does that make sense? Trying to rephrase things, especially this one's the most obvious example. Now,